Okay, so here are some ways to represent graphical data. We have dot plots, histograms, and box plots. Now you may have seen a dot plot before. A dot plot is just, it can be called a dot chart too. It's just a statistical chart that consists of data points plotted on a fairly simple scale. And we use closed circles to represent the data set. So if we look at this, this dot plot here, how we read this is we would say, okay, there's 5 dots on 10, 6 dots on 20, so 6 values of 20 in your data set, and so forth. Okay. A histogram is slightly different. A histogram is a graphical display of data using bars instead of dots, and the different heights represent the frequency of the number in the data set. In a histogram, each bar, though, represents a group of numbers into different ranges. And so these 2 bars are in the range of 8 to 9. So we don't know if, what data points are 8.1 or 8.2. We just know that there's 2 in the category between 8 and 8.5. And then there's 6 points within the range of 9.5 to 9. So we don't know exactly what each data point is. As opposed to dot plots, we would know exactly what each data point is within the set if we were reading the graphs. And then box plots, these are sometimes called box and whisker plots. A box plot uses something called a 5-number summary and it is represented on the graph. So we don't know what the data points are in the statistical in the stats that are given, but what this is useful for is because it quickly shows you key values within your data set. And so I'm going to dive deeper into box plots. So this whisker represents the minimum point in your data set. The left part of your box, part of the box and whisker plot, represents your quartile 1 value. This line in the middle, or it's not in the middle of the box, but this line inside of your box represents your median. This line on the outer edge of your box represents your quartile 3 value. And this line, this whisker on the end, represents the maximum point in your data set. These are the 5 numbers in the 5-number summary. And this box plot represents those 5 numbers. Now, what's cool about a box plot is we can easily see the quartile 1, the median, and the quartile 3. Remember, the median splits your data in half. So if the median splits the data in half, that means that this would be 50% of the data, and this would be 50% of the data. Okay. Now, the quartile 1 value is halfway, the half point for the first half of the data. So the quartile 1 value actually splits, and sorry, I don't know where that M came from, actually splits even further. So this is 25% of your data. And in between your quartile 1 and your median, that's also 25% of your data. And then same with your quartile 3. Your quartile 3 is the half of the second half of the data. So this means that this between the quartile 3 and the maximum point, that would be 25% of your data. And in between the median and the quartile 3, that's another 25% of the data. So what that means is that also in between the quartile 1 and the quartile 3 value, that is 25 plus 25 is 50% of your data is represented in your box. and it's the 50% of the data within the box that is closest to the median and the mean. All right, so I know that was a lot of information, but we'll get the hang of it as we get going. So number one, this is a dot plot. Charlie's Food Factory currently employs 28 workers whose ages are shown below on the dot plot. We're going to answer the following questions based on the dot plot. So this is a dot plot. It's very easy to see how many points are represented in each data value. So for example, how many workers are 18 years old? So if this is 15, then this is 16, 17, 18. So I'm looking here. So there's 1, 2, 3, 4. That's it. You will just count the dots. So there's 4. What is the shape of this data? Now on dot plots and histograms, it's very easy to see because we can easily draw in that bell curve and see that there's a tail on the right side here. So that means that it's skewed right. We will learn how to determine whether a box plot is skewed left or skewed right or symmetrical. But for dot plots, we just followed the same thing that we learned in the previous lesson. Now it says the mean age for a worker is 22 years old. So if I look at 22 on my box plot, that's this dot right here. They're saying that is the average age of our worker. Now they're saying, why would the average of 22 years old not be representative of a typical worker? Well, if we look at this dot plot, there's only a few workers that are older than 22. Whereas if we look at the cluster of dots that are under 22, a majority of the workers at Charlie's Food Factory are actually under 22 years old. So the mean actually is not a good representation of the data, where I told you before the mean is most of the time the best representation of the data. But here's an example where the mean is not, because we could clearly see that a majority of the workers are under the age of 22. In the next lesson in level 3, we will actually talk about why in this example the mean would not be a good value to use. But let's explain it how I explained it right now. This is not representative of a typical worker because a majority of the workers are under the age of 22 years old. And that's it. All right. So now let's move on to the next page. Now we're going to look at a histogram. So in a histogram, this example really clearly shows you that we don't know the exact data points within this first bar. We know that there's 9 workers that fall into the category of 16 to 18 years old, but we don't know how many 16-year-olds, how many 17-year-olds, or how many 18-year-olds there are within the 9 workers that fall into that category. So that's a disadvantage of a histogram. Now, we have how many workers are within 19 to 21. So that's this bar here, and how you read that is you just look at the frequency, and that would be 11 workers. And then what is the disadvantage of the histogram compared to the dot plot? Again, we don't know the exact number of workers in the 19 to 21. We know the exact number of workers in the 19 to 21-year-old range, but we don't know exactly how many 19-year-olds or 20-year-olds. Whereas on a dot plot, we do. We can easily count the dots within each of these values here, and it's not given in a range. So a disadvantage of a histogram is we cannot specify how many workers are of a certain age in a histogram compared to a dot plot. And that's what I wrote here. Okay, and then what is the shape of the data? Again, in a histogram, you can easily tell because you can draw that bell curve in to see that, oh, we have a tail going to the right again. So this is skewed right. All right, number 3, now we're getting into the box plot. So with a box plot, we have 20 of Mr. Jensen's chemistry students recently took a quiz, and these are the results of the quiz given in the box plot. Now a reminder, the box plot doesn't show you what each student scored. Instead, it shows you the 5-number summary. So we can see that the minimum score was a 53. The quartile 1 score was a 64. The median score was a 71. The quartile 3 score was a 76. And the max score was an 84. So it seems like this quiz was kind of hard for these students looking at this data. So again, what was the median score of Mr. Jensen's chemistry quiz? Well, we said 71. And then what score was greater than or equal to 75% of all the other scores on this quiz? Remember that between the minimum and quartile 1, this is 25% of your data. So 25% of the students scored between the minimum and the quartile 1. Between the quartile 1 and the quartile 3, this is 50% of your data points. And then between the quartile 3 and the maximum, this is another 25% of your data points. So if we want the score that was greater than or equal to 75% of the other scores, well, that means that this is the 75% of the lowest values. So, this is 75% of the lowest values. So the score would be the quartile 3 value, which was 76. So the student that scored a 76 was actually in the majority, in the 25% majority of the highest scores. All right, Mr. Jensen regularly sets the passing grade on his quizzes to be the score of the 25% marker on the box plot. So what would the passing grade be? Well, the minimum to the quartile 1 value is 25% of the data. So we're actually looking at the quartile 1 value, which was a 64%. That is passing on this quiz. That was a really tough quiz. And what is the shape of the data? Here, we can see that a majority of the points fall in this area here, which means we are skewed left. So how you look at that is you look at your median. And if your median's closer to the right, that means it's skewed left. If your median's closer to the left, then it's skewed right. If your median's in the middle, then it is symmetrical. Which one of the following has the greatest medians? Be careful, you need to look at the scale. So here your median, oops, I jumped. Here your median is 30, according to the scale. Here your median is 40, according to your scale. Here your median is 22, according to your scale. And here your median's way low. So number 2 would be a greater median. All right, that brings us to the end of this lesson.